Okay, so hello and welcome. I'm actually going to turn up the volume a bit so that way I can whisper. Hello and welcome, here we are. So, because I think people are sleeping now, I don't want to yell so loud. Alright, so here's the deal. So I'm going to turn up the volume a bit and keep my voice low. But we're going to go ahead and continue where I left off. And yeah, so... oh, wow, alrighty. Get rid of this because this is not what we need. Oh man, I'm so annoyed. I am very much annoyed. Okay. Alright, so we're going to do the following. Let's reread the problem here. Excuse me, I don't really need the memory. We are going to use strings, vectors, unordered maps, and excuse me, queues. So, give a string S an array of strings, words of the same length. Return as all starting indices of substrings in S. That is concatenation of each word in words, exactly once in any order and without any intervening characters. You can return the answer in any order. Okay. Yeah. So, interesting question. You may want to read it a few times, but you got some examples. Bar, foo, the foo bar man. Foo bar 09. Word, good, 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 best word. Word, good, best word. And bar, foo, foo bar, the foo bar man. Bar, foo, the 6912. So, the way we're going to approach this problem is we're going to figure out what the word length is, which all the words are the same length, right? We're going to build a frequency map of all the words that we need. We're going to count all of them. We're going to build we're going to take a queue of words we're going to make use of. We're going to frequency map queue. We're going to count how big the one word is, right? We assume the number of words we have at least one. So we can always just take the first word in the array. And what we're going to do is, for each value modulo, I guess we'll call it k. K is the size of a word. For each value modulo k, we're going to iterate. And what we're going to do is we're going to run character by character through the queue, starting off at that index for that modulo value. And what we're going to do is we're going to process, let's say, k characters at a time. That'll be a string, right? It'll create a string. Checking the frequency map if that string is there, and if we're going to have another frequency map that we count how many of each word that we've considered so far. If that word is in the frequency map, and we can add one more to our frequency map, so we haven't exceeded the total, then we push this word onto our queue. We also keep a running tally of how many total things are in the frequency map to begin with. Once we have the total number of words, right, the words size, or the number of words in the dictionary, if we reach that point, that's a match, and we can take the index that we start at with our queue, and we can add that to our return vector. Now, a couple things here. We're going to make an optimization with the queue, and we're going to use integers instead of the whole words pushed into the queue. And we're also going to keep track of the beginning of the queue. So there's like a current value, current index that we're going to keep track of. So I push that current index on the return. Next, what's going to happen is if the word is not the next word, so after a match, the next word, basically it must be the case that either it's not in the array or it exceeds the amount in the frequency map. If it's not in the array, then we can pop the whole queue and move the current index up to where we are at the moment, with the index of the character we're at the moment, that we're considering at the moment. It would be the next index. Yeah, it would be the next character, the next one. So you can pop the whole queue down, empty the queue, and just move all the way. However, in our frequency map, we're not just going to count how many. We're not just going to count how many of the. In our frequency map, we're not just going to count how many we see. We're actually, the frequency map is going to be a vector of integers as well, and those integers are going to tell you at which index did we push this. At which index did we push this particular word in? And what we're going to do is we're going to pop the queue and add at each point to the current index each word value. Keep popping, keep adding until we reach that index in the frequency map. Really, you don't necessarily know. I mean, you could do it another way where you could say, like, well, just take the difference between these indices, the current index and that index. That tells you how many times you should pop, and then just update to the new index. That works too. Then, what's going to happen, though, is you're going to pop that word as well. So actually, a better way to do it would be to push into the array the next index, rather than the index that you found it at, but the index following that word. That way you pop that word as well. Then you can decrement the frequency map. You can remove that index from the frequency map, from the stack. Actually, it should be a queue, I'm sorry. The frequency map should be mapped, the key should be keyed to frequency, to queues, not to stacks. So you can pop the front of the stack there. I'd rather pop the front of the queue there, and also pop the queue you have, and then continue from there. And then actually push into the queue the new word that you just found that matched. So you can pop all the way down and then add the new word and update the index. Not update the index, update there's a current index, and then there's a you're just going through each character. So yeah, you can just keep going. One issue there, by the way, is you also need to check when you add that new word, check the total as well. So before you add the new word, you do all that popping, then you add the word and check the total. So you push onto the queue, check the total, and then you might add that new index as well. And that's it. That's the whole algorithm. You just keep doing that. And there will be a point where once you run off, like once you've considered all the characters, then you're just done. And you go to the next loop. And then you reset the queue. So that's it. That's the whole algorithm. And obviously you do it, quote unquote, k number of times, where you start at that sort of modulo value. And so you end up with an O of n times k algorithm, and it's not too bad. So we'll do something like this. So that's the description. Hopefully that makes sense. And we're going to say for int I equals 0, I is less than k, plus I. We're going to say for int j equals 0, j is less than s dot size plus j. This character c equals s of j. We're going to have a return vector of strings, call it ret. Return, oh sorry, it's not strings, it's my mistake. I'm not sorry, but my mistake, I made an error. Each time we're going to have a new queue, so a standard queue of ints. And by the way, this line optimization, we're not going to push the strings into the queue, we're going to push the index where we begin that string. So now we have for each character, and we're going to have a string s, or just x, we'll call it, or just current string, that's probably better. And then we also have integer current index. We start off at 0. I actually should start off at I. Yeah. And they should also start off at I as well. Slight mistake. Okay. So now what we're going to do is say current string plus equals C. So we bend C to the current string. We say if. And we have frequency maps as well. Build a excuse me, frequency map. Count each word, the frequency of each word. So for const standard string reference S in our we'll call it W in words. We're gonna have an unordered. We're gonna have 2 unordered maps of strings to their count, which is gonna be an int. We're gonna say frequency map, or just frequency, and then we're gonna also say unordered map of the string to the queue of ints, and this is going to be not the frequency, it's the current frequency, something like that. Let's do current frequency, it's better. So for each word, we're going to say frequency of W plus plus, and we're going to say current frequency of W is equal to a new queue, an empty queue of integers. And yeah, so we update that. Okay. So now we're going to say if current string, and we're going to count if current frequency dot count of current string. We actually should just use if it's in the frequency map at all. If that count is at least is non-zero. What's interesting is I think this actually counts the keys. This doesn't count the value itself, which is peculiar. So it could really be frequency or current frequency, but we'll just say frequency. So the frequency count of current string. So we said found a new word, or so process the current string. Yeah, we can do this once every time. I think that's fine. There's maybe a slight optimization where you only check at every sort of modulo bound, but we don't really have to do that. I think it's okay. No, actually, no, we do have to check at every modulo bound. I'm sorry, I take that back. Yeah. So we're going to say, so we'll do 2 things. If j modulo k is equal to I modulo k, right? So yeah, so that's kind of interesting, but also I'm not sure which one of these happens first. You can always just add the precedence operators here, or just add parentheses to make sure. Yeah, so if j modulo k is equal to I modulo k, then we process the current string. Now, I think we don't have to. I mean, the first string we don't really doesn't really do anything. Shouldn't really do anything. Well, actually, that's a good question. That's actually a very good question. Do we start off at I minus 1? Because what if you have strings of size 1, right? 1 modulo 1 is 0, but 0 modulo 1 is also 0. that's really tricky. That's very tricky. You should have one character in there when you're at 0 mod k. Let's see, when you're at, okay, so let's say 5 mod k is 0 mod k. You should have a full string. I'm trying to think how to do this properly, so... yeah, I modulo k. Really, it's just I. It's not really I mod k. I want to say something like... when, because j, let's say it's 5, right? So you can say I is 5. Or yeah, 0, 1, 2, 3, 4, 5. That actually would be 6 characters. Yeah, what's interesting is actually when I is 29, it means 30 characters. Or when k is 29. So actually we should make this equal to 1 less than or equal to k. If we're going to say modulo k. And then that way we actually say j is I minus 1. I think that's a little bit better. A little confusing, but a little bit better. So then we say this is I minus 1 as well. Is that right? So j modulo k, if k is 1, and j starts off at 0, that would be I minus 1 is 0. Let's say, yeah, let's say I is 6, right? So 5 characters, I minus 1, 5 characters. J is 0 initially. 1, 2, 3, 4. 0, 1, 2, 3, 4 means it would be 5 characters. And then when you reach... so I think actually we should do something like this. It's really confusing, but so if we have I is 5, that means that, and this actually isn't k, this is modulo I, by the way, because we're going off of those bounds. Oh no, I'm sorry. Oh, that's so confusing. Oh, this is so confusing. Yes, it's correct. So if k is 6, and I is, oh, it's so confusing. I had it right the first time. I is 0, I is less than or equal, less than k. I is less than k. And this is modulo k. And you start off at I. What you're going to say is j modulo k is the first index we start at. Let's say k is 10, right? You want to go to 10 characters to the right, puts you at I guess adding 10 to j. Let's say j, so let's say everything starts off at 0. It's very confusing, but everything starts off at 0, right? Want to add 10 characters to j modulo 10 gives you 0 again. So it's 0 back to 0. This is when we want to process the string, but we don't want to add any characters yet. We should set the current string to empty here, by the way. Now, because the first time we checked this, there shouldn't be anything in the string, so the frequency should just be 0. Yeah, but the next time we check, when j modulo k is equal to I, again, 10 characters later, we should have a string of 10 characters. If we have one character, now the problem with this though, is that we're not going to process the last character. Not going to process the last string. Yeah. So, we just have to check. That's very tricky. That's like a really subtle thing. But yeah, so yeah, because when we go over to the end, we want to process the last string. Like if we had, if k was 1, so every word was just a single letter, which technically could happen, then we'd do the first processing, but the string would be empty. We would do the next. We would have added a character to the next processing when j is on the next spot. That's super confusing. That's extremely confusing. Hi, how's it going, Melito? Welcome back. Hello, hello. Welcome. I realize I've just been like kind of not rambling, but going on for almost 9 minutes since you've been here. I appreciate it if you've listened to all of that. Super confusing, I realize. But we want to make sure that we don't try to process. We don't want to try to process one. We want to make sure we have the full string before we try to process it. Well, I guess we could add the character that we're processing on. Can we do that? I mean, it'll fail every time. The check. If we swap, can we swap these two? Maybe we can. Just thinking. We can add the character and then process. Yeah, I think that's fine, actually. I think it's okay to do this. Because even if there's one, that's where it causes problems. If you're processing one character, add that character, process it, and go to the next thing. Yeah, it's fine. I did this wrong. I mean, I did it wrong, but it's okay. It works out okay. Process the current string. So anyway, yeah. So we can add the character first, and then process the string, and we'll say if frequency of current string is greater than or equal to, it's going to be the current frequency of the current string. Oops. Dot size. Total count in the queue. Then we would process. So actually, these are really, you do each of these. Do this one. Actually, there are a few different parts to this. So I say if this, and then we have sort of an otherwise that we do. So otherwise, we could pop the entire queue, pop entire queue, and reset the current frequency. If we have another integer, which is the total. Target total as well. I guess you could do that. Alright, so current total, target total. We actually could just get this each time. I don't think this really, we don't need to do that. Alright, so current total. So current total is going to be 0. And we're going to say the Q is going to be Q equals a new Q of integers. We're going to say for const standard string W in words. We're going to set current frequency of W equal to a new Q. That's if, yeah, we don't find anything. We're going to reset the whole thing. And we update our current index to, that's important, the current index I want to update to, did we set K up here? Yeah, we did. Want to reset our current index to, I guess it would be J plus 1. Yeah. Because that'll be the start of the next word. Yeah. Right. If we see the string, if it's there, now we have some questions here. If our, in the case, current string that we wish to process that is found in the frequency map, we either add, and I either add to the map and check the match, or pop the Q and check the match. So in either case, we're gonna check the match. So actually, that's this part. So I think in all cases we're gonna update the current string to empty. In all cases. Okay. Update the current string to an empty string. So again, so here we're gonna pop our Q as is appropriate. So we're going to say while this is the case, while this is true, we're going to take a string x, set that to current frequency of current string dot size, and it's going to be, or we're going to say int which index, or actually we'll say there's going to be a target index. Right, target index is the front value of that frequency map, right? Current string front. We're gonna get the target index there. Then what we're going to do is we're gonna say while this is the case here, this current string, we're gonna basically we're gonna get a bunch of substrings really. Now this is interesting. Oh boy. What's the runtime for the substring routine in C++? Because I kind of don't want to use. What's the runtime? Linear and count. Oh, nice. Oh, perfect. So actually, I really could use substrings for this routine over here. I probably should have actually just used substrings. Now I'm thinking about it. Let me actually rewrite this. This is kind of awkward. So it's not going to be the current string anymore. It's going to be you could say for each word, I guess the word count. It's actually not the word count. It's going to be it's going to be the word count. Yeah. J equals 0. J is less than words dot size plus J. We're going to say standard string current string is equal to s dot substring. And we say there's a count, so there's an index, and a count. The count is k, and the index is, I guess we could do, I mean you could do it this way too, j plus equals k. And we're going to say j plus k is less than words dot size. It's k minus 1 characters. Or I don't know, if we're an index, including j. I'm trying to think this through. Hold on. Yeah, if instead of character counts, we use indices for everything here. So j plus k minus 1 is that how many indices you're going to move forward. That has to be less than or equal to the last index of word size. So this should be fine. You could just add 1 to both sides. That's interesting. J plus k is less than or equal to words that size. Yeah, I mean, I think it's right. You could just also subtract 1. I think that was the one that I was kind of curious about. So anyway, yeah, you could add k each time, and then you can take the substring for j. And that's a little bit cleaner than adding characters and resetting the empty string and all of that stuff, all those things. Also trying to use modular arithmetic here. I think it's a little bit easier. It's also a little more obvious too, what's happening. So anyway, so let's see. We don't really need this character anymore. We really don't care about that. Okay, so we have our current string. We don't need to update the current index. Oh, actually, we should update the current index. Yeah, we should have a current index still. So it starts off at I, and then actually J really is that current index. Well, no, not exactly. No, this is the beginning of the queue. This is like queue index. That's probably better. Queue begin index. It's better than current index. Let's see, so. Alright. Current string is string that's found in the frequency map. Then we have some things we do. If it's not found, pop the entire queue and reset the current frequencies. Yeah, I think that's fine. Current total back to 0. Queue begin index now gets updated to the, it's actually going to be J j plus k. And here we have, right, so we're going to keep popping here. So say target index is the front of, so there's a target index, and there's like string, call it x, is, or just q front. It's going to be q begin index s dot substring q begin index. Okay, so that gives us the front. That gives us the front string in our queue. Which we actually like have a queue, so we don't really need to do it this way, but we could say like just x, I don't know, q dot front. So how's this gonna work? We're gonna say if our frequency of, really it would be the other way around, it's less than or equal to, right? So we need to pop the q. If our total frequency is less than or equal to this current frequency size, then we need to pop our q until that's no longer the case. And what we're going to do each time is update the front of the queue, its index, until this condition is resolved. We have a target index, which, right, that's how far we need to go until this condition is resolved also. I'm sorry, I take it back. So we don't actually want to do it that way. That's not the way to do it. I take it back. Is that what we, wait, no. Yeah, we know we do want to do it this way, yeah. That's so confusing. We actually don't need this target index either. We don't need any of that. We could just take the q front and then just pop q front, and we're going to say current frequency of x dot pop front of the queue, and that really should be it. I think that's the whole thing. And each time we update q begin index plus equals k, right, or the size of x, really. Yeah, that's a little confusing, but that's what should happen there. Yeah, that's actually really confusing. We have a lot of redundant data we're working with here, I guess. And each time we're also going to update our total. Yeah. We also want to say, well, this is always going to have something in it, right? This current frequency of x, it has to have something in it. So we pop x from the front, and we also q pop. So I pop this from the frequency map and from the yeah, so that's a little bit confusing, but pop from the frequency map, pop from the queue, update our beginning index of the queue, decrement our total things in the queue. Actually, this total is unnecessary as well, because the queue size is all we need for that. Yeah. We do need the queue begin. We don't need the total. We don't need the current total. We don't need any of that. We don't need total or current total. Yeah. size, it's fine. So now we say, right, just keep popping things, and from the queue and from the frequency map, and then we say process the current string. So we're going to say current frequency of. So do we even really need the indices of each of these? We really don't. That's actually not true. Yeah, we don't need the indices. Yeah. Yeah. So these don't need, so we can actually do even one more optimization here and just make these integers. Okay, process the current string. So now we're going to add the string back. We're going to say if q, and we're going to say q dot push current string. Say if q dot size is equal to words dot size, then we're going to ret push back q begin index. So that's confusing, but yeah, that's where that is. That's how you do that. And that's pretty much it. That's pretty much it. This also just set to 0 all the words. I don't really know. Pretty sure there's a way to just clear this queue. You can just do that, I think. Something like that. What happens when we do this? I'm very curious. Does it compile? Let's start with that. Excuse me. No. Starts off at 0. It's kind of unnecessary, but we'll just do that too. Queue front. Oh, these aren't integers. Oh, I was thinking I wouldn't use integers for the queue, but that's fine. We'll use strings. That's okay. We could just get the substring every time, but really don't need to do that. Is there a way to... There are like a few different ways you could do this, I guess. So I'm getting a little hung up on all the different things. So can I? I guess we can't just pop everything. Okay, all right, it's fine. We'll just make a new queue. It's probably better to just make a new queue. I don't know. My output's nothing. So it's wrong. But it only took 11 milliseconds, that's pretty good. That's interesting. Let's, oh, okay. Copy this. How are we doing on time? 45 minutes, wow. Even, like, knowing the answer already, it still just takes me forever. Oh, it looks like I can't get the... Let's get the test cases. Let's use the example test cases. What is going on here? Okay. So, like, nothing gets pushed. Okay, so we have K, I, J is I, J plus K minus 1 is less than words dot size. That's actually, it should be S dot size, not words dot size. Might have something to do with it. Runtime error, length error, okay, basic string. Okay. Is it this one? Oops, okay, hold on, come on. Let's see. Oh boy, I forgot to. Sorry about that. Sorry about that. Check. I think it should be check 1, check 2. And I will always wonder what's going on. What is this length there? It's not that. What's the issue? I'm so confused. And I will always wonder why this doesn't work properly. I won't always wonder that, but where is this happening? Let's see. Debug 5. Check 5. Check it out. What's it all about? Okay. So 10, 20, 10, 20, 10, 20. 5 times. Check 5. Okay. Also, which test case is happening on? Is it the first one? Let's see. Let us see. Alright. It's actually correct. What? We did it. We did it. We did it. Somehow it's correct. How does that happen? So this one is the one that's wrong. Do we have the same issue on the other one? I'm curious. What is going on, man? Yeah, both of them have issues. It's really weird that the first one is correct. Sort of out of nowhere. Alright. Check 5. 10, 20, 10, 20, 10, 20, 10, 20. So 1, 2, 3. 3 times it executes. And... okay. Word good. It should have... yeah, so... once we see this third good, so let's actually print the current string. Where is this happening and why? Is the question. Is la question. Is la question. Word good good. Okay. So after word good good, just error. Alright. The second, so word good. Yeah, so word. No, we don't enter this loop at all. Push. Now we get good. And we push again, and then we see good again. We say, hey, 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 hey. We say, okay, this frequency is equal to this current frequency. So we're going to set an X in front of the Q. We're going to say while this frequency is less than or equal, we're going to decrement our current frequency and pop. So we pop word, update Q begin. We say Q equals the front. Oh, I see. That's the issue. I think that's the error. If Q is not empty. Because you could end up emptying the Q, which is actually what we did. It's a very slight thing, but that's what I did. Yeah, that's my mistake. Do we submit this? I didn't mean to submit this. Why is it taking so long? Why? Oh, it's taking a really long time, brother. It's taking like 10 minutes. Hello? Did it break? Did something happen? Maybe we should copy paste this code. Let's try again. I think we broke it. Oh, okay. Code's still there. Alright. Alright, let's try that. Okay, works fine here. Let's try the other examples. See what happens. Might run into other errors. Quite possibly. Oh, okay. Those are correct too. Okay. Interesting. Just get that debug code out of there. That's kind of a subtle thing, but yeah, it happens from time to time. There's more debug code here. More debug code. And I will always wonder what's going on. Okay, I guess we got it right. I don't know. Seems okay. Oh no, no. 99999. Alright, 52, yeah, it took us quite some time. Let's see which of these is the one causing errors. Is it this one? Or it's the latter? Is it the former or the latter? Is the question. Yeah, man, there are probably some subtle errors in here. So actually, what's interesting is that this could be, I think it's actually happening here. So if the frequency of the current string it's very interesting. Where is that happening exactly? It must be happening here, but how could the Q be empty with the current frequency? How is that possible? I'm assuming this is where this is occurring. Right, that's the only other thing I can think of that's causing issues. Yeah, what? How did that happen? How's that even possible? Impossible. Impossible. Okay, well, we could say QVN string. Impossible. for Q begin, you've got another one, which is Q size. Well, it's empty. Current string, maybe. We'll do a current string. I don't know, I'm just thinking any debug information that would be useful here. There's one more thing we want, which is the index J. And will always be wondering what's going on here. So Q begin is 1, current string is A, J is 1. What is going on, man? How did this happen? How could this happen? I don't understand. I don't understand. Must have made some kind of an error somewhere. I think it's a typo or something. Frequency of current string. Frequency of current string. Oh, I know what the problem is. Oh, there we go. That's supposed to happen here as well. Reset Q. Yeah. That's probably why. That might be the issue. It's a little weird, but that might be the problem. There we go. Yeah, if you have like lots and lots of duplicates, I guess that would happen. Alrighty, I think we got it. I think we're done. That only took almost a full hour. I'm tempted to go for it here. There are some test cases that are these correct though? I think these are right. Why doesn't it give me? Alright, well we're gonna get rid of the ones at the bottom. Because it's giving me a hard time with those ones. And we're gonna just say there is one in particular, so it's ABC, AX. Oh no, well actually BYZ, AB, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then good, yellow, yell, good X, good A, yell B. And then we'll just say, I don't know, ABC, AX, BYZ, AB, good X, good A, good B, good X. Good A, yell B, good X, and then pop another good X, and then you just say, what do you have? Good X, good A, yell B, good X, good X. Good A. Or actually, you could do good A, yell B, good X, good X. Then we would just need ABC, AX, BYZ, AB. Something like this, I don't know. Probably should just randomize some test cases here. Yeah, we're over an hour. Alright. Wow. Even after solving the problem in my mind, it still took me an hour just to code it. It's kind of complicated, I don't know. Alright, let's go for it. I don't know. Maybe there's something I missed somewhere. I hope not. I hope not. Hey, we got it. Hey. Alright. 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 Yeah, I was pretty sure I solved this one. That's a really long running time though. It's a very long running time. Uses quite a bit of memory and it's not very fast overall. I think there's a, let's just try to run it again, see if we can just randomly get a better running time. Not really, it's pretty consistently like 400 something. That's interesting. One more time. Yeah, okay, this is kind of a slow solution. So there's probably, like the discussion, they probably could explain it some more, but this was kind of rough. I think I can make it faster if we don't put the strings in the queue and we just get the substring each time. We could try that also. So we could try, the queue could be also, by the way, yeah, I guess the map is fine. Q could be ints, and we could say, instead of x, we could say standard string x equals q dot front, and then substring s, the substring each time, and then that would give you okay, and what you would push onto Q is not the current string, but the, oops, I meant to do that, but you would push the J. Something like this. I think this also works. Let's try it. Interesting. Oh no. Oh, yeah. Oh, wait. Oh, okay. How about that? There we go, okay. Looks like we're still correct. Let's go for it. I could be wrong, but I don't know. Alright, that's not much faster. That is really not much faster. Doesn't use much less memory either. Yeah, because yeah, okay, we'll go back to what we had then. I think it's simpler just to use the strings as they are. One more time. So, I mean, it's maybe a little bit faster without the copying the whole string each time, but not much faster. Yeah. So I think the issue is this is just a slow approach. This is just a slow approach. I don't know what to say. I don't know what to say. I mean, it's fast enough where it works, but doing this each time for each k, each index I, each beginning index, I think is kind of expensive. That might be part of the issue. it's relatively straightforward. I think part of the problem also is this current frequency, updating this each time. That's kind of expensive. Wondering if maybe there's a way to like reuse this frequency map. Maybe what we can do is maybe instead of using two frequency maps, having this current frequency, we can just decrement the frequency, and then when you pop everything from the queue, when you clear it, you would update all the frequencies back. So instead of setting all these frequencies to 0, you would just increment the frequency map, and you would loop through the queue, so you'd pop everything off the queue and update the frequency map again. And yeah, then you wouldn't be recreating these queues each time, and you also wouldn't be performing this every time. You'd just be looping through the queue each time. I think that's a better, more efficient way to do it, actually. So yeah, there's probably, if we made that optimization, I mean, while we're here, might as well do it, right? Let's just see what that would look like. So let's get rid of the current frequency. And we're gonna say Q. We actually could set this all the way from the beginning. And we could say, instead of current frequency, we're going to take while not q.empty, x equals q.front, frequency of x plus plus x dot pop, if not q.empty, x equals q.front again. Actually, you don't need to do that again, do we? Yeah, we don't. Also, yeah, we can actually put this over here. I didn't really think about that either. By the way, I think that's, yeah. I'll come back to that in a second. But, yeah, you can run the frequency. So while frequency is greater than or equal to 0, I suppose. How do we do this? I think it's less than or equal to 0. Yeah, so we can update this too. By the way, we don't need this while loop either. We don't need the if part. We can just make that a while loop. Process the current string. It's all in the other direction too, by the way. Push the current string. If queue size equals word size, then push back. Alright, pop the entire queue, reset the current frequency. So we're going to say for, so while queue empty, say string x is q.front, q.pop, frequency of q, increment. Alright, something like this now. Not sure exactly what's going to happen, but something like this ought to work. if I don't make too many errors here, presumably. Hey, we're correct. Okay, sweet. Let's go for it. There might be things that I missed here. Oh no, elf. I like that. Hey. Whew. There we go. There you go. That's what I like to see. It's like 10 times faster and almost 97%, almost 100%. One more time. See how we do. There we go. We're like almost 99%. I think if we kept trying it, we can get 100%. There you go. That's how it's done. Beautiful. Talking to me about asymptotic time complexities, huh? Oh no, that's not what I meant to do. There we go, beautiful. That's a lot faster. So we're not creating a queue every time anymore. And yeah, it's a lot more efficient because we just don't have to don't have to maintain multiple maps and compare them to each other. We also got rid of one of the branches here too. Excuse me. So yeah, pretty clever approach. Very efficient, comparably. Nice. All right, I'll take it. That's pretty good. We're gonna run it one more time just for good measure. Yeah, 98%. We had like almost 99% a moment ago. It's pretty good. All right. Thank you for watching. I will end it here. Have a good rest of your day. I mean, it took a lot longer than I was expecting, but thanks for coming by, saying hello, Melito. I appreciate that. And yeah, I hope you all have a good rest of your night. I don't really know what else to say here other than we did it. I don't know. We did it. All right. Take care. Bye.